All right, so before I get started on the actual notes, I want to talk to you a little bit about interest. Where have you heard the word interest before? Money. What kinds of money? Paychecks? Not usually paychecks. Where? Loans. Buying a house. Buying a car. One of the most frequent places that you will see interest would be either your savings account or a credit card. Okay? So, there is good interest and there is bad interest. Good interest is interest that benefits you. I'm sure that you have joked at some point in your life about loaning somebody money and having them pay you back with interest, right? Because that benefits you as the loaner. That gives you more money than you ended up loaning out, right? Bad interest would be if you're on the other side of that transaction. You borrowed money and then you have to pay back more than you actually borrowed, right? So I want to talk to you for a minute about interest because you guys are at a very critical point in your life. When you, for some reason, right around when you turn 18, credit cards swarm on you guys. You will just get applications like crazy for credit cards. You probably already get asked about them now. Every time you check out at a store, every single store has their own credit card that you can open. And, oh, you're going to get 20% off today if you use this and blah, 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 blah. The reason they target 18, 19, 20-year-olds is because you guys are the ones that they can make the most money off of. Because most 18, 19, 20-year-olds don't fully understand how it all works, and they end up getting thousands and thousands and thousands of dollars in debt. Okay? So I want to tell you a little bit about the bad kind of interest, and then I'll talk to you about the good kind of interest. I'm going to kind of knock on banks a little bit. Banks are good, but they're also bad. Most of us like to think of banks as good places, but you always have to remember that at its core, a bank is a business, and a business exists to do what? Make money. So even though banks seem like good places at the end of the day, they are still trying to make money off of you. You're not going to get something for nothing from a bank. All right? So you may have currently a savings account. Raise your hand if you have a savings account. Okay? You may or may not know it, depending on how involved you are with your savings account, but you get a statement every month. A statement is something they mail you in the mail, and it says, you have this much amount of money in your savings account. Thank you for being a customer of Bank of America or wherever. Let's say in your savings account, let's say you have $100. Hopefully you have more than $100 because you've been saving for a little while. But just for ease, I'm going to use reasonable numbers that we can understand. Now, you have the option of opening your savings account at Wells Fargo, Bank of America, the local credit union, Chase. You've got all these different options, right? So how do they make you come to their bank instead of somebody else's? They offer you what's called interest. So your savings account, when you get your statement once a month, it'll say that your balance is $100, but at some time there will be a thing that says interest earned or something like that, and they'll give you a penny or something like that, so that at the end of the month you end up with $100 and 1 cent. And that 1 cent is literally like, thank you for banking with us. We appreciate you as a customer. That's our token of gratitude to you. Okay? Now, why aren't they going to, well, let me step back for a minute. The reason why that's so little is because the interest on a savings account is tiny. The interest on a savings account could be like 0.25%, like 0.25%. It's tiny. Why is that going to be such a small amount of money? Because the bank is a business, right? The bank wants to earn money. Are they going to earn money by giving you a lot of money as a thank you for banking with them? They're not going to earn much money at the end of the day, are they? So that's a good kind of interest, but it's a teeny tiny amount of interest. So people always ask themselves, okay, if I want to save money, how can I find something that's going to pay me more than just that teeny tiny amount? And that's when they start going into stocks and mutual funds and all sorts of other things, CDs, bonds, whatever. All of those kinds of things that will help them earn money faster than a savings account. Okay? A savings account is not a place where you invest money to make more money. A savings account basically keeps your money safe. It's not going to help you earn a lot of money. So the other side of this is when you have a credit card from that bank. That's where they make their money, and they make a lot of money. So let's say you have a savings account, and then you decide, all right, I'm going to open a credit card. And they say, okay, you have, what do they say? 0% balance transfer or something like that. That's if you have another credit card, you can move how much you owe over to this one. Most credit cards have a ridiculous interest rate, something like, I'd say 17 to 23% last time I checked, somewhere in there. So here's how a credit card works. Let's say I went to Chase and I opened a credit card and they gave me a credit limit of $500. What that means is they will loan me up to $500 in 1 month to spend on whatever I need to spend it on. So in other words, let's say I open that this month because I need to buy Christmas presents, and I go and I buy my Christmas presents, I swipe my credit card. I'm not actually paying anything out of my bank account. Visa's paying for me. They'll send me a bill later, but Visa's actually covering the bill right now. Let's say I spend $450 in the month of December. Okay, that's how much I spent. And then in January, I get a bill from Visa, and Visa's saying, okay, we would have loaned you up to $500. You only used $450. Good for you. And now you need to repay us the $450 that we loaned you so that you didn't have to take it directly out of your bank account. Does that make sense? That's what your credit card bill says. If you can pay them the $450, then you pay them $450 and you're good. That's how you positively use a credit card. That's a way that is not going to harm you in any way. Okay? My dad is one of the most brilliant money guys that I know, and they have 3 or 4 credit cards, but they pay them off every month. They never charge more than they're able to pay off. The problem comes with this. A lot of times when you open a credit card, the credit limit they give you is that. Not $500, but $5,000. And then they say, okay, you spent $4,500. Now your bill is for $4,500. $450 is a lot more manageable than having to write a check for $4,500 out of your paycheck or out of whatever you're bringing in the month. So what happens then? This is where credit cards quickly become very dangerous for people. There's a lot of 18 to 20-year-olds that probably have $50,000+ in debt because of stuff like this. So they say, okay, well, we understand you can't pay $4,500, so we'll just ask you to pay at least the minimum payment, and then you can pay it off every month by paying a little bit and a little bit and a little bit, which sounds like a good idea. But let's say the minimum payment is $500. So you pay $500 in January. What does that leave your bill at? If you paid $500, you still owe them $4,000, correct? Now, where does this interest percentage come in? Well, this is where they say, okay, well, since you couldn't pay that, we're going to charge you interest. Let's say we'll charge you 20% interest on that. So what is 20% of 4,000? Well, how do I solve that? 4,000 times 0.2, not 400. 4,000 times 0.2 is $800. So in other words, you paid $500, but they're charging you another $800 in interest. So even though you paid off money, does it feel like you paid off money? No, because your bill is still higher. That sucks, doesn't it? And then the next month it's no better. You pay another $500 off, well then you got $4,300 left to pay. They charge another 20%. they're not going to, that's why they have such high percentages here, because this is how they end up making money. And what happens if you get to a point where you can no longer pay your credit card? That's when they start having collections agencies call you because you owe them money. And legitimately you do owe them money because you purchased more than your bank account could cover, right? Because if your bank account could cover it, you could have paid it off at the end of the month and been free and clear, right? So anyways, this is where banks make a lot of money. All that to say, credit cards are not bad things if you can pay them off at the end of the month. If you can't pay them off at the end of the month, they can get you in a lot of financial hurt really, really fast. So be very, very careful with them, okay? So that's bad interest. So let's talk about how interest is calculated, okay? Let me use a basic example here again. Let's say I have an account where I have deposited $100. Okay, and let's say I deposit $100 at the beginning of January. And let's say this is an investment, so I'm going to earn interest. And let's say it is compounded, meaning they're going to calculate it every year, which means that if I have 10% interest, then in the next January, so 1 year later, they're going to give me 10% of that. What's 10% of 100? $10. So they're going to give me another $10. So my balance at the next January is $110. Does that make sense? And then the next January, would they add another $10? No, they would add 10% of this because this is my new balance, right? So 10% of $110 is $11. So now I'm up to that. Yeah? So in 2 years, I've gone from $100 to $121. Okay? That's if they calculated it every year or they compounded it every year. What if they compounded it every month? Well, if I deposited that in January, then it wouldn't be the next January that I have $110. It would be February, and this would then be March. So in 2 months, as opposed to 2 years, is when I'm earning it. What if they compounded it every day? That would be January 1st, January 2nd, January 3rd. And so it would grow specifically like that. So what we're going to look at is different amounts of money invested at different percentages, and how does it differ when you're calculating it different amounts of times. Does that make sense? So we have this formula, and this formula is fairly ugly, but it's important. In fact, if you memorize this formula, you should do just fine on the test. If you don't memorize the formula, you will struggle with every single question. I don't even know if you can get them right. You really need to know this formula. And I'm going to talk about what each of these mean. Starting off with A. A would be your answer, or your amount at the end of the problem, or at the end of your investment time. P is your principal, not your principal. That's Mr. Jaramillo. Your principal is your initial amount of money that's in your account. So if I'm looking right here, if I invest $200, my P value is 200. Okay? And then it's always going to be a 1, and it's always going to be a plus. Unlike the last word problems we did where it could be a plus or a minus, these ones are always going to be a plus. R over N. What's R? The rate. Sometimes it's called the APR, the annual percentage rate. Okay, but that's your R value. And then N happens to appear twice. Do you see N here? N is the number of times compounded, and that's what I'm going to talk about here in just a minute. And then T is the time. So for example, this one's compounded for 2 years, so time would be 2 years. But let's talk about this N thing, because that's how many times they're going to calculate it. And specifically, the N is referring to how many times per year they're going to calculate it. So if they say they're going to compound it annually, that means they are calculating it one time every year. So your n value would be 1. Semi-annually. You know what that means? Every half year. So in 1 year, they would calculate it 2 times. What about quarterly? How many times would they calculate it per year? If they're calculating it quarterly. 4 times in 1 year, right? Once every quarter or once every 3 months. So that gives them 4 times total within a year. What about monthly? How many times per year if they're calculating it monthly? 12 times per year. What about weekly? 52. Daily? 365. Now we're going to get into some crazy ones. Hourly. How would I figure that out? 365 days times 24 hours in a day. They're going to calculate it 8,760 times a day. FYI, computers probably do the calculating, not actual humans. Every minute. Okay, if I know how many hours there are in a year, how do I find out how many minutes? Multiply by 60, because that's how many minutes are in an hour. Anybody ever seen Rent, the musical? There's a song called 525,600 minutes. That's how you measure a year. Okay, little reference there. Every second, I would take that and do what? Times it by another 60, because that's how many seconds there are. 315360000. And that's just ridiculous, isn't it? Now, all that to say, most of our problems will stop here. Will probably be one of these values for n. Okay? I probably won't give you ones like this, but in the example that I showed you, I'm hoping that you noticed it, that the more frequently it's calculated, the more interest is earned, right? So you want the interest to be calculated as much as possible when it's benefiting you, because it's going to grow your balance faster. So eventually we're going to get to this thing called compounded continuously, which means it's just going constantly. More often than every second, it's just constantly going. And that's when we use this thing called E, and we actually have a fully different formula down here, and I'll get to that in a minute. That's this formula right here. Okay? I'm not going to talk about that yet. I want to get the basis down of these guys first. Okay? So, let's look over here. We have $200 invested at 16% APR for 2 years. If it is compounded monthly, what is my balance at the end of the month? Or, at the end of 2 years. So I'm going to use my formula. The amount will be equal to, what's the principal? The starting amount, $200. And then I have 1 plus my R value. Now your R value must be in decimal form. It cannot be a percent. So how do I turn 16% into a decimal? Move the decimal 2 places. Another way, if you for some reason are getting confused with moving the decimal places, take the number itself, divide it by 100. That moves the decimal 2 places for you. So it's 0.16. Over n. If it is compounded monthly, what is my n value? If it is compounded monthly, what is my n value? Anybody? 12. All to the 12 times t. What's my time? 2 years. So I have to figure out how to plug that into my calculator, and then I've got my answer. So it's actually very simple once you figure out how to plug it into your calculator. Now, most calculators, watch very carefully. You are going to need to put another set of parentheses right here around your fraction, and another parentheses around your exponent. Then you should be able to type it in just as is. So 200 parentheses 1 plus another set of parentheses. Do not use your fraction button, by the way. We're dealing with decimals anyway, so let's just leave it decimals. 0.16 divided by 12. How many sets of parentheses do I need to close here? 2. Close, close. Now I hit my exponent button to the parentheses 12 times 2, close my parentheses, and I get an answer of 274 point, what should I round it off to if I'm dealing with money? 84. Hopefully it's a no-brainer that you give it 2 digits past the decimal for money. Now, really quickly, I started off with $200. If I ended up with less than $200, either I'm investing in the wrong place or I did something wrong. Because if you are investing money, you should be getting more money, right? You shouldn't be losing money, otherwise it's a bad investment. So 200 to 274, all right, we grew, that's good. Okay. If I wanted to know what I got compounded daily, how would that change? How would it change what I just calculated? It's still the same amount, 200. It's still 0.16 as my decimal. What changes? The n value. This was n equals 12. What would compounded daily be? N equals 365. So I need to put a 365 down here. And then up here, 365 times 2, because n occurs twice in that formula. So again, if I calculate this, 200 parentheses 1 plus, open another parentheses, 0.16 divided by 365, close how many parentheses? 2. Now hit to the parentheses 365 times 2. And yes, that's a lot of parentheses, but we have to make sure that the calculator recognizes the order of operations that we need it to. Otherwise, it just does things left to right for some reason. So what have I got here? 275 point what? What would I round this off to? 406 would round off to 41. So if I had the option between compounded monthly or compounded daily, what would I choose? Daily. It's only $1 more, but it's $1 more in my favor as opposed to the bank's favor, right? What if I wanted it compounded continuously? Well, here's where I have to use this new formula. I call this one the Pert Plus formula. Have you ever heard of Pert Plus? Nobody? Makes me feel old. So Pert Plus was like the first ever shampoo and conditioner in the same bottle. It was revolutionary. Just kidding. But this is the shampoo. And why do I remember Pert Plus? Because look at the formula and look at the name of the shampoo. It just helps me remember the formula. Okay? Now, I understand what P is because that was in the other formula. I understand what R is. I understand what T is. I don't know what E is. Okay? Now, E is a number. It's a number that's come up with in calculus. And this is the calculus statement. It says as n approaches infinity. In other words, as this value gets really, 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 really big, this whole thing approaches E, which is this number. So on your calculator, there is an E button, not a capital E. It should be a lowercase. Most of the E buttons look like this, E to the X, and it should be somewhere around your button that says LN. Looks like IN because it's a lowercase l. So mine's right here, my LN button. The E to the X is right above it. So if I wanted to know what E to the first power is, that's just plain old E, right? So if I want to know what E is, I do E to the first power Most often your calculator will force you to put an exponent on that e. And it's 2.718 blah, 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 blah. Now, e is always that number. Just like pi is always 3.14, e is always 2.72 when you round it off. Okay? But what's nice about e is we never actually have to memorize what e is. We're just going to use that button in our calculation. All right? So, compounded continuously. That's what tells us, this is our key word here, it tells us don't use this formula anymore. Use the Pert plus formula. So, what's my principal? It's still $200. And then I have e, and then my exponent would be r, which is 0.16 times what? The time, which is 2. So in my calculator, what does that look like? 200, and then my e button. And if you have trouble finding the e button on your calculator, come see me when I'm done with the notes. I'm more than happy to help you. And then 0.16 times 2. And I get 275 point what? 425, so that becomes 43. So if I have the option of compounded monthly, daily, or continuously, which one would I choose? Continuously. It's only a little bit more, but it's more. And it's only a little bit more also because I'm only investing $200. If I was investing more than $200, the difference would be bigger. Okay? So there? Okay. Let's look at the next one. This one is a larger amount of money, but what? A much smaller percentage rate. So let's see what happens here. Okay, we also have a much longer amount of time. We've got 25 years. So if it is compounded semi-annually, that means our n value is what? What does semi-annually mean? 2. Means twice a year. So my formula from up here, I need the principal first. What's the principal here? $1,500 times 1 plus 0.025. Now, I always struggle when it's a decimal, changing it, when it's a decimal percent, moving the decimal again. So I'm going to put the 0.025 divided by 100 and let the calculator do it for me. Oops, I divided it by 10, didn't I? So I need to move it one more time. 0.025 divided by 100. There we go. 0.00025. And if you want to just move the decimal by hand, that's fine also. Over n, n is 2 to the 2 times 25. So again, in my calculator, I need another set of parentheses around my fraction and another set around my exponent. So I'm going to go plug this in, 1,500, and then 1 plus parentheses, 0.00025 divided by 2. Close how many sets of parentheses? 2. To the 2 times 25? 1509.40. Now I'm going to write the rest of the decimal just because to show a point in a minute. 3768 is what comes after the 40. How does compounded weekly change? That makes my n value what? 52. So I'm going to take this exact same formula, but here where there's a 2 on the bottom and here where there's a 2 in the exponent, I'm going to change it to a 52. So I'm going to come up here and insert that 5 so it says 52. And I get, what do I get? 1509.40. 4335 is the rest of the decimal there. Again, that was 1,500 times 1 plus 0.00025 over 52. to the 52 times 25. So parentheses there, parentheses there. Any difference? The difference is past where it's going to affect my dollars and cents, isn't it? It's not even a penny's worth of difference. What about compounded continuously? That's going to be my 1500 e to the rate, which is 0.00025, times the time. What's the time? 25 years. So 1500 e to the 0.00025 times 25. 1509.404358. Any difference there? Again, the difference is so far out there that it's not making a big impact. What do you think the biggest factor is that makes this consistent regardless of how often it's compounded? The percentage. The percentage is so stinking tiny that it doesn't really matter. When your percent is a little higher, it does make a difference though. Okay? All right, next page. My favorite types of problems. This is a question that smart people would ponder in their life. Okay? Bill wants to make a one-time investment to save for his child's college education. So in other words, he has a kid who's just been born. He wants to know, how much money do I have to deposit now when my child is 1 day old so that I have this much money in 18 years to pay for that kid's college? Because $30,000 in one chunk is a lot of money. If I could invest something now and have it grow, then I won't be out of pocket as much in 18 years. I'm setting myself up for a smarter decision in the future. Does that make sense? My dad, I think, did something similar to this. He set aside a certain amount of money, and then 1 year later, he set aside another amount of money so that he would have money for my sophomore year of college. And another year later, he set aside another amount. And he did that 4 times so that for 4 years of college, he had money that matured to an amount that was usable for college. Okay? All right, he has 2 investment choices. What should he choose? First option is he can invest at 15% interest compounded daily. Second one is a higher interest rate but compounded less frequently. So, what's different about this one is we don't know the principal. We don't know what the current amount of money he's going to need to invest in. We know instead that guy. What is that guy? He wants to end up with $30,000. So, I don't know the principal, but I do know the rest of the information. This would be 1 plus, what's my R? 15% interest, that would be 0.15 divided by N. What's my N in this case? Nope. N is 365 because we're compounded daily. All to the N, which is 365, times what? The time. What's the time that we're looking at? 18 years. It's going to be invested for 18 years. So how am I going to solve this? Because I'm trying to find what P is. How would I solve this? I'm going to figure out what this is, right? And then what am I going to do with it? 30,000 divided by that will give me what my current principal needs to be. So how do I do that on my calculator? Well, let's do this part. I remember I need to put a parentheses there, right? So 1 plus, actually let me open up parentheses. 1 plus parentheses, 0.15 divided by 365, close 2 sets of parentheses, to the, open up one last set, 365 times 18. And I get 14.87148,107. don't worry about writing that down on your paper. Okay? Don't clear it off your calculator either. I'm going to show you another trick on your calculator that is very useful. Now, what did I say I was going to have to do? Once I found out this value, I was going to have to divide both sides by it, correct? So that's the 14 point blah, blah, blah. Now, if I just hit right now divided by 30,000, does that get me my answer? Because I don't want 14 divided by 30,000. I want 30,000 divided by the 14, right? So do not clear your calculator. Just start typing 30,000, and it should have automatically cleared your screen, right? Divided by, and you're going to use this button that says ANS. Mine's right above the negative sign down here. Do you see that? So I have to hit second and that, and so this is what my display says. It says 30,000 divided by answer. That means it's going to take 30,000 and divide it by the previous answer that I did not clear out of my calculator. That 14 point blah, blah, blah. It's automatically plugging that in for me. Okay? Because if I were to round off that 14 point something, I would lose some accuracy. So I want to just let the calculator remember that for me. What do I get? 2017.28. Somebody tell me that's a good idea to deposit $2,000 now, which is a lot of money, but it's a heck of a lot less than needing to pay $30,000. That is a darn good idea, right? I can scrap by $2,000 right now. I can figure that out. I can work that out. That's not even a full paycheck. That is a lot harder to scrape up, right? Okay, so with option A, he has to invest $2,017.28 in order to have $30,000 in 18 years. Let's check option B. He still wants $30,000. This time it's going to be 1 plus 0.16 over what? What's my n value? 12. All to the 12 times 18 years. So again, I'm going to calculate this whole portion first. So 1 plus parentheses 0.16 divided by 12, close two parentheses, to the 12 times 18, also in parentheses, and I get 17.47, blah, 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 blah. So I'm going to divide both sides by that 17 whatever. And again, how do I do that on my calculator? I don't clear it. I just hit 30,000, 30,000, divided by second, and mine's the negative sign, so that it says the previous answer. And I get 1716.398. What's that going to round to? 40 cents. Which option should he choose? First one or the second one? Which one should he choose? Why the second one? Because he has to deposit less money to earn the same amount in the end, right? This one only cost him $1,700. This one cost him $2,000. Not too shabby, right? So if you think about it as a parent, if you can deposit the $1,700 when your kid's born, and then for the first couple years, then you've got a nice little amount of money up there for when your kid gets to college, if they choose to use it for college, or if you want to open that up to whatever other things they wanted to do with that money. Okay? Questions? All right. Happy studying.